Hello, I'm an old guy and I do maths. Now, today we're going to expand this expression here, 2x plus y to the 5, using binomial theorem. The assumption in this video is that you already have a nodding acquaintance with binomial theorem, and so we'll just go through the mechanics of doing this. We'll expand each part of this and explain how it works. But if you want a thorough explanation of binomial theorem, there's another video in this playlist which goes through binomial theorem from beginning to end, right from the start, and explains everything. Okay, so we have this expression 2x plus y to the power of 5. And we've got according to binomial theorem, we've got about three things to do. We need to sort out what the coefficients will be, and for that we can use a row in Pascal's triangle, the sixth row. Note that is 5, this is from row 6. And so just to go through this quickly, the coefficient according to Pascal's triangle of this expression here raised to the power of 5 would be 1. So this is 2 to the power of 5, x to the power of 5, y to the power of 0. Y to the power of 0 is 1. We'll get into these more fully in a moment. The next thing that we need to do is we need to follow the pattern of the powers of x, which will be to the power of 5, to the power of 5 minus 1, to the power of 5 minus 2, to the power of 5 minus 3, to the power of 5 minus 4, which will be 1, we'll put a 1 in there, and to the power of 5 minus 5, which is to the power of 0. So you could write in here, if you felt so minded, x to the power of 0, which is 1. And the coefficient of that expression here is 1. Because it is also 2, can I squeeze that in there? 2 to the power of 0, x to the power of 0, if we're being picky about it. Okay, now, the y's. Over here we start at y to the power of 0, which is 1, y to the power of 1, 2, 3, 4, 5. So we've got the familiar pattern. The powers of this expression here diminish by 1 as we move across the equation, and the powers of this expression here start at 0 and grow by 1 as we move across the expression. Okay. As I said, we get these numbers from the sixth row of Pascal's triangle. So what I've done is I've taken this number and I've gone through the other way in which you can get this value. Again, if you've seen binomial theorem before, you'll have seen this notation, which is n choose r. Those of you who are familiar with probability might have seen this. This is written in combination form, and there's usually a function on your calculator for calculating these numbers. So I've decided to take the third expression here and just work through it. Okay, so in this case n is 5. So 5 factorial over 2 factorial, because we are choosing 2. That's this if you will, times 5 minus 2 factorial. And this works out, by the time we've done a little bit of cancelling, which I will do here now, this works out to 5 times 4 over 2 times 1, which is 20 over 2, which is 10, which gives us that number. And this is the formula for this and for this. This is just the notation for this. N choose R. N, in this case, is always the number up here, and R grows from 0 as we move across the expression. So initially R starts out as 0, and this is 5 factorial over 5 factorial, which gives us 1. Okay, so I hope that's clear. Now, the next thing we're going to do is we're going to go through each of these expressions individually. And here we are. So, same equation, expanded 32x to the 5th, 80x to the 4th, y, and so forth and so on. So let's have a look at how we get each of these expressions. I should write in, and I will do this here, 2x plus y to the 5th, just as a reminder to us of what we're dealing with. Okay, so the first expression here, using Pascal's triangle, we have a multiplier for the coefficient of whatever the expression of x is. In this case it's 2x. So we have 1 times 2 to the 5th x to the 5th. Okay, 1 times 2 to the 5th x to the 5th. This is the expression, as you see in binomial theorem. This is A. All of this is A. You can't ignore this number. So 1 times 2 to the 5th x to the 5th, y to the 0, which gives us 32. 2 to the 5 is 32. You can do it on your fingers. 2, 4, 8, 16, 32. That gives us this expression. The next expression, Pascal's triangle tells us that our multiplier is 5. So 5 times 2 to the 4th, which gives us 80. 2 to the 4th is 16. 5 times 16 is 80. X to the 4th, y to the power of 1, which gives us y. Next expression. Our multiplier is 10. So it is 10 times 2 to the power of 3, which is 8. 10 8s are 80. X to the power of 3, because we're moving across here, and every time we move along we subtract 1 from the powers of x, and we add 1 to the powers of y. So 10 times 8 times x to the power of 3, y to the power of 2, which gives us 80, x to the 3, y to the power of 2. Next one, our multiplier is 10 again. And by the way, we can calculate these the long way if we want. Just going back to this, we also have this method here of calculating each of these multipliers for whatever the coefficient of x might be here. So where was I? I think I'm here. 10 to the power of 2 to the power of 2. 10 times 2 to the power of 2 is 40. X to the power of 2, again we're subtracting. Y to the power of 3, again we're adding. That's this expression here. Next expression, 10xy to the 4th. This is our multiplier for the coefficient. 5 times 2 to the power of 1, if you will. is 5 2s are 10. X to the power of 1, we've moved down 1 again. Y to the power of 4, we've added 1. And we get 10xy to the fourth. And the very last one, which is just down here, is y to the power of 5. We'll work backwards this time. Y to the power of 5. Why is there nothing else here? Because we have x to the power of 0, which is 1, 2 to the power of 0, which is 1, times 1, which was the multiplier up here. And that is how we expand this. Now, with a little bit of practice, this becomes quite simple. So you take a look at this and you go, your first expression is going to be 2 to the power of 5 times x to the power of 5 times y to the power of 0 multiplied by 1. Second expression, 2 to the power of 4. 2 to the power of 4 is 16. X to the power of 4. Y to the power of 1 multiplied by 5, which gives us 80, x to the 4, y to the 1, and so forth and so on. I hope this has been helpful. If you feel that this was a little bit beyond you, go and have a look at the Introduction to Binomial Theorem, which is another video in this playlist. Thanks for watching. See you next time. Bye.